Ladies and gentlemen, thank you for the invitation to address this august body. There's really two things I'd like you to take away from this short talk. One is collaboration. Ian has spoken about it. Collaboration across government, industry, different bodies, even between competitors. And also, a key word here is sustainable. So 2050, it has to be about what is sustainable. Royce, we use jet fuel. Jet fuel comes from, is largely using fossil fuels. So the challenge for us is sustainability. I'm privileged to look after and direct the resources of nearly 10,000 engineers. And we won't attract young people into this industry unless they believe it's sustainable and it has a purpose. So first thing to do is to sort of just contextualise what we do and aviation generally and the industry. First point I'd make is a kind of economic point, which is the sheer size of the aviation industry and its contribution to worldwide economics. And it's staggering really if we look at how many jobs are supported worldwide, and indeed also the transport of goods. It may surprise you, like talking to an airline which some of you know, Finnair, great airline, big customer of ours, and it surprises me that there's sort of fish and all sorts of things being transported between Finland and Japan. And it's extraordinary what is transported around in the belly of aircraft. Lobsters are taken from Boston to the Middle East by Qatar. These are extraordinary things that are going on that most of us are not aware of. We go to restaurants and we wonder why we're eating fine food, but it's all brought around generally by aircraft. So that's the economic situation. And then this is important to me. I'm a parent, like many of you. What is the case for aviation apart from economics? Well, I have a strong belief that bringing people together, breaking down barriers and cultural misunderstandings means that there's less likely to be conflict. Societies are isolated. There are problems with those, as we can see around the world. So there's a benefit there. There's also these other experiences that people can have, and we can argue about the benefits or otherwise of those things. But for sure, underpinning what we do has to be a benefit. Most of the people I work with every day are engineers. They need to know there's a purpose to what they're doing, not just an economic purpose. So the challenge for us is we can see the economic benefits of aviation and huge growth in aviation, and that brings its own challenge. There's a growth in aviation of around 4 to 5% a year. A lot of aircraft will need replacing, and that's a good thing in some ways because the aircraft that then brought into service are more economic, they use less fuel, they're less noisy, etc. It's a very long-term business. Ian spoke of it. So, in particular, aircraft we're delivering today, engines we're delivering today, will be in service for 25 years. Smaller aircraft, A320s, 737s, maybe 18 to 20 years, but long-range aircraft, 25 years. So, in some ways, the future is going to be fixed in 2050. Some of it is fixed even in the next few years. So, tomorrow is really today. So, again, we'll be familiar with this. What is the contribution of aviation, particularly in relation to carbon dioxide? It's around 2%, but the issue is that it's growing. So, we have to sort of challenge ourselves on that, emissions from fossil fuels. Of course, all these other areas are of interest to the company I work for because we're interested in other transportation systems. We have a business that makes very large diesel engines, we have a nuclear business, and so on. So can we address some of these other challenges that society faces? So our experience is it's a broad experience, which is to bring our knowledge in electrification is one particular area where we believe we can make significant changes in aviation. And we're successfully doing that in trains at the moment. So you may not be aware of this, but when you go to somewhere like King's Cross, there's lots of sort of fumes from diesel engines sort of spitting out smoke. That's going to change as we introduce hybrid trains, where they can pull out the station and run for several miles on batteries before the diesel system cuts in. It's quieter, and it's a way of avoiding massive investment in electrification. So these are happening. UK Rail and Irish Rail have ordered these train sets. We're investing in hybridisation of gas turbines, etc. If you look at the yacht on the far side, the future of yachts, they'll come into the harbour on electric and other shipping on electric systems, battery systems, so they'll be quiet and silent. As well as the efficiency gains, there's also the environmental noise and other pollution gains. And then finally, and I appeal to government on this, is that Rolls-Royce as a company has a very strong belief in small modular reactors. Very large reactor systems, 1.6 gigawatt and so on. These are very, very expensive investments, massive commitments over many, many years. They're huge bets. And our kind of view is to take what we've done with submarines and use that to a more productionized system where you can produce and put down a nuclear reactor in more like sort of 3 to 4 years and build lots of the same thing rather than each power station being unique. And scale matters, because as you shrink it down, you can plug into the existing systems. So we're trying to use our knowledge in these places to apply it in aviation. So we have some challenges, CARE challenges, ATAN challenges, industry and academic world and government have set some very ambitious targets. And we can see them, and we have made huge progress. I mean, if you live in London, and I was brought up in London at the end of the ILS beam into Heathrow, where aircraft turned in, aircraft have definitely got quieter. Not just engines, but airframes and flaps and all kinds of other things. There has been an enormous step change. And also, not just quieter, but huge amounts less carbon dioxide emitted into the atmosphere. So we have made huge strides, there is no question about it. But so much more to do. Look at the aggressiveness and the ambition of these targets. And they have to be real, because otherwise, I come back to it, it won't be sustainable. So what's our strategy? And I'm not here to sort of promote Rolls-Royce to you, I'm just giving you a view of Rolls-Royce's view about this. And it matters because when I started with Rolls-Royce was 9% of the long-haul market, and today it's nearly 50%. And long-haul travel is a major contributor to a challenge for us on sustainability. So what we plan to do is really do three things. One is to evolve the gas turbine. So I came from this morning, I was reviewing a project to take 1% out of an aero engine, 1% improvement in efficiency. It will cost us hundreds of millions, and it's a sort of 4 or 5 year endeavour. So gas turbine technology is honed and honed and honed. Between us and General Electric on one particular aircraft, there's only 1% difference. This is very mature technology. So taking out a percent here or there is very difficult. But we'll continue to invest in that because there's much more to come as we change the architecture of engines. A big prize is sustainable aviation fuels. So fuels that don't compete with food stocks. There's no point driving up the price of wheat and causing rioting in various countries, and especially unstable countries around the world. So these are sustainable aviation fuels that don't compete with food stocks. And then finally, explore radical alternatives. And this is a very, very exciting area. And Ian, we're working with Cranfield and other institutions on trying to bring this to life. On large engines, don't worry, I haven't got time to talk about this very exciting world that I live in. I get very excited about this stuff. But there's material system changes, there's architectural changes, and for those who are passionate about engineering and gas turbines in the room, thermal efficiency and propulsive efficiency, we've got to work on both of those. We just tested the world's most powerful aerospace gearbox, over 70,000 horsepower. And it's extraordinary the things that we're doing in pushing science, physics, our understanding of engineering right to the limit. Lots of things, but just one thing, just a material. One material change we're making inside the engine. It's a 10-year endeavour to bring that to life. So these are very, very long-term plays. Now what will probably interest you more is this whole world of disruptive technology, electrification. And our view is that electrification, all electric, is potential with battery technology and growth in that. Could take us out maybe 200 plus miles. My ambition is, before I retire, is to make sure I can provide the propulsion system, or Rolls-Royce can, for a plane that people pay, passengers pay to get on that's pure electric, and that's closer than perhaps we think. I'm very, very excited, and I hope you are, by this plane down the corner. Royce is working in Project AXO in partnership with government and others to break the world speed record for electric flight next year. The aircraft is in construction now, we'll hopefully do that off the coast of Wales next year. And then you see these different ways that we're trying to bring electrification to light. Now, of course, there's no point electrifying unless the supply chain of electricity doesn't come from brown coal or other pollutants. But this is a very, very exciting world we're stepping into. Our chief executive, Warren East, he said recently, I'm envious of young people starting out today, because this is a wonderful challenge, a very exciting period of technological change. So that sort of portrays the challenges and the things that we've got to work out. What's the right voltage? You know, as you go up in voltage, the conductors come down, but then you end up with issues about dielectrics and all sorts of things you have to worry about. So these things haven't quite been worked out yet, but they will be worked out within the next year or so. So I believe that there will be, and we believe as a company, there will be a revolution in regional flight to compete with high-speed rail, road, freight, and so on. And if you can envisage an aircraft that is got distributed propulsion, these may look a bit strange to you, but if they're quieter, if you distribute the propulsion and they're inherently quieter, we don't need to worry about nighttime curfews. We can imagine vertical flight as well, so we don't need massive infrastructure. This is very, very exciting. And using hybrid power, so you've still got a gas turbine and jet fuel, but you can envisage a different aircraft that enables different economics. So this is it's an exciting prospect. But silence, basically very quiet flight, and vertical flight is a possibility there. So we've already had this picture of these great characters. You don't have to guess who they are or anything, but they're CTOs of major organisations, Airbus, Boeing, etc. I think this is a great thing that companies that generally compete need to collaborating in this space. Now that's a good thing, I think. It's not about competition here. It's about the whole industry. So how can we make sure it's sustainable? And these are the elements that we're working on. It'd be great to be run engines on purely sustainable fuel, but there are some technical challenges with that around elastomers and so on. So just to sort of finish up, these are what we're working on fuel. I've sort of covered that. Running 100%, as I say, is a challenge because modern aircraft can deal with this fuel. The problem we've got is that older aircraft can't because they have natural rubbers in them, natural things like nitriles and so on. So, people want fuel to cover everything. If you want to take advantage of this, you may have to have a different view about that. So just to finish up, it is much more than just about the aircraft. I'm sure Martin will cover this later, but I look at aircraft sat in stacks, I look at taxiing. If you take your foot off the brake on a large aircraft, it accelerates to 60 knots. That's how much residual thrust there is. So we're wasting energy all around the place. So we need to look not just at the flying bit, the propulsion and the aeroplane, but everything else that goes along with it to really, really leverage a sustainable future. Thank you very much for listening.